Question 7, we have a particle projected from a point P up an inclined plane. Here's my really poor attempt at a horizontal. That's a bit better. So here's my inclined plane. And the speed is 4 root 2g, 4 root 2g, or 4g root 2, whichever way you choose to write it, meters per second. And this angle in here, we'll call it the angle A. The inverse tan of A is 1 over 3. Opposite over adjacent, so we're going to have root 10. So the cos of A is 3 over root 10. And the sine of A is obviously 1 over root 10. The plane is inclined at an angle theta to the horizontal. So here's my angle theta. My accelerations. Well, let's set up our initial vector first. We have u, which is 4 root 2g, by the cos of A, which is 3 over root 10 in the I direction, and we have plus u 4 root 2g by the sine of A, which is 1 over root 10 in the j direction. This tidies up to be 12 root 2g over root 10, 12 root, put 3 in there as well, yeah, 4 3s are 12, 12 root 2g over root 10 in the I direction, plus 4 root 2g over root 10 in the j direction. They can tidy up a bit, but I'll leave them like that for now. So we're told that this particle is moving horizontally, so it's striking the plane like this. So the angle is theta. So we need to get our velocities for the landing angles, but first of all we need to get the time taken to strike the plane. That's going to come from the displacement in the y direction, ut plus a half at squared. That reminds you to write out the accelerations. So in the I direction, my acceleration is going to be minus g sine theta, and in the y direction, or the j direction, minus g cos theta. And we don't have any values for theta, so we're going to find these. So we have u in the j direction is 4 root 2g, 4 root 2g over root 10 times t, minus 1 over 2 by the acceleration, which is minus g cos theta, which we have the minus in already, so g cos theta by t squared. This is going to be equal to 0. So factoring out my t, I'll get 4 root 2g over root 10 minus g cos theta times t over 2 equals 0. So my initial t is equal to 0, or 4 root 2g over 10 is equal to g cos theta times t over 2, just to do it the long way. So we have 8 root 2g, 8 root 2g over g cos theta times 10, so 10g cos theta, 10g cos theta is equal to t. My g's cancel. 8 over 10 becomes 4 over 5, so I have 4 root 2 over 5 cos theta is equal to the time taken. This could also be written as 8 root 2 over 10 is root 5 by root 2. There'll be a cos theta there, so it could be 8 over root 5 cos theta, or 4 root 2 over 5 cos theta. So we need to apply our information to v of x and s of x, sorry, v of x and v of y, to get our velocities, so we can apply them to the landing angle. So let's do v of x first. U plus at for 12 root 2g over root 10. Well, I'm going to simplify that down, and here it is here, 12 root 2 over root 2 by root 5. Just cancel the root 2s, might be a bit tidier. 12g over root 5 That's u, and then the acceleration we have is minus g sine theta times t, which is, when we take the root 5 bit because there's a root 5 in the other one, 8 over root 5 cos theta. Sine over cos is tan, so we have 12g over root 5 minus 8g tan theta over root 5, 8g tan theta over root 5. So if we get a tan theta in v of y as well, we will be able to solve for theta. So we have 4 root 2 g over root 10, 4 root 2 g over root 10, which is 4g over root 5. So we'll take this for the y. So the velocity in the y direction, u, 4g over root 5. The acceleration minus, we have g cos theta times t, which is, what do we say, we'll take the root 5 one, 8 over root 5 cos theta. You can see here the cos thetas will cancel. So we get 4g over root 5 minus 8g over root 5, which is just equal to minus 4g over root 5. And we know that the tan of the landing angle is equal to minus the velocity of y, so that's going to be 4g over root 5 over the velocity of x, which is 12g. We have the same denominator there, so it's 12g minus 8g tan theta all over root 5. The root 5's cancel, and we're going to cross multiply now to get tan theta times 12g minus 8g tan theta is equal to 4g multiply it out, 12g tan theta minus 8g tan square theta equals 4g. We can divide across by g. We can divide across by 4 to get 3 tan theta minus 2 tan square theta is equal to 1. So we'll get 2 tan square theta. Let's see if we're going to factorize this. 2 tan square theta minus 3 tan theta plus 1 is equal to 0. So it has to be 2 tan theta by tan theta to give me 2 tan square theta. It has to be a 1 and a 1 to give me 1, and it has to be 2 minuses due to the minus in the middle and a plus at the end. So we can say that 2 tan theta minus 1 equals 0 or equals 1. So tan theta, I don't know why, 0 came out there. Tan theta is equal to 1 over 2, or tan theta is equal to 1. So that would be theta being 45 degrees. And if theta, the tan of theta is 1 over 2, the inverse tan of 1 over 2, theta is equal to 26.56 degrees are my two angles. So what else have they asked in this question? Going back through all our work. If tan theta is equal to 0.5, find the magnitude of the velocity which the particle strikes the inclined plane at Q and determine the total energy at P and show that it is equal to the total energy at Q. Okay, let's do tan equal 0.5 first. We have the velocity of x and the velocity of y. Do beside them. So we have v of y, and v of x just has tan theta in it. If we allow tan theta to be 0.5, we're going to get 12g over root 5 minus 8 by 0.5, that's 4, so minus 4g over root 5, which is going to be 8g over root 5. So these are my two velocities. So the magnitude, we need to get the square root of 8g over root 5 squared plus 4g over root 5 squared. It's going to give 64g squared over 5 plus 16g squared over 5, which is equal to the square root of 80g squared over 5, which is the square root of 16g squared. Yeah, square root of 16g squared, and the square root of 16g squared is just 4g. So this is the speed in meters per second. So now we're looking at the total energy at P and the total energy at Q. So we've got our mgh for potential energy, and we have a half mu squared or mv squared for kinetic energy. So these are what we need to apply. Let's just remind ourselves what the speed was at the start. 4 root 2 g, 4 root 2 g, so a half mv squared. There's no height involved for the beginning, so this guy is equal to 0. So this is a half m by 4 root 2 g to be squared, which is a half m by 16 times 2 g squared, 32 g squared, which is 16 mg squared. 16 mg squared is the energy at P, or at the beginning. So now it's now up here, started here, and now it's up here. So we have to get this height. So we have the angle theta, so we can use the angle theta to help us get the height. But first, to get the height, we definitely need to get this value along here, the range along the x axis. So this is s of x, my ut plus a half at squared. We have all of these values. The u was 4 root 2 by the cos of theta. That was the angle A, wasn't it, from above, times t, minus 1 over 2 times the acceleration. Just check here, and shouldn't need to go back this far. G sine theta, which is the angle that the tan of theta now we're saying is 0.5, and we have 3 over root 10 for cos A. 3 over root 10 for cos A. And we have the tan of theta is equal to a half, opposite over adjacent, so root 5. So we have minus a half times g sine theta times t squared. So filling these values in, 4 root 2 by the cos of A, which is 3 over root 10 times t. Just remind ourselves what t was. We had this, we simplified it down to this guy here, 8 over root 5 cos theta. And the cos of theta is 2 over root 5. So they'll cancel. Then we have minus a half times g by the sine of theta, which is 1 over root 5, by t squared, which is 8 over root 5, so it's going to be 64 over 5 by cos squared theta, and cos theta is 2 over root 5, so we're going to get 4 over root 5. So these will cancel. And tidying this up, we're going to get, just will cancel this 2, and that'll make it that one a 2. So 2 by 3 by 8, 6 8 or 48 root 2 over 10. 48 root 2 over 10 minus, I'm just seeing I cancelled out the wrong here, that should be a 5 here. 5 still alive, so we're going to have 64g over 8 root 5, 64g over 8 root 5. So that's going to be, I got rid of the root 2 by saying 48 root 2 over root 5 root 2 minus 8g over root 5. So we get 48 over root 5 minus 8g over root 5. I did leave my g out of the initial 4 root 2 here, g. So I just need to bring that g back in. I knew that was missing. So what's that leave? That leaves 40g over root 5 for my range. So now applying this to my triangle here, I can say that the sine of theta is equal to h over x. So x sine theta is equal to the height, which we need for mgh. So x being my range, 40g over root 5, by the sine of theta, which is this is my theta triangle. The sine of theta is 1 over root 5. That's going to be 40g over 5 for my height. So mgh, m times g by h, which is 40g over 5, which is just 8g. So mgh is 8mg squared, and we need to add a half mv squared. So that's a half times m times v squared. What was the final velocity? Was it minus 4g? I think we got 4g. So we need to apply our 4g. So that's 8mg squared plus a half m times 16g squared, which is also 8mg squared. So that's going to give 16mg squared, which hopefully is what we got. That's a q. What did we get? A p. 16mg squared. 16mg squared. A 17-minute question. Just pray to God it doesn't come up in the exam.